A1 and A2 are parallel to B1 and B2, then you are going to have the line AB is perpendicular to B1 and B2. A2 minus A1 dot B1 cross B2 will be is equals to 0. 12 minus 15, which is nothing but minus 3. So minus 6 minus 4 is minus 10. Minus 10 minus 3 is minus 13. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt a different concept of a 3D geometry and based on that problems. In today's session, dear students, we are moving on to the other concept of 3D geometry, which is a chapter number 11 in your second PUC Mathematics. Right now, we'll be moving on to the one more derivation, which is very important for your examination based on those problems. Okay, so here we'll be having first a coplanarity of two lines. So what will be the coplanarity of two lines in vector form as well as in the Cartesian form? For that, I am going to consider the two lines. Such two lines will be like this. See, R vector is equals to A1 vector plus lambda into B1 vector, and R vector is equals to A2 vector plus lambda into B2 vector. These are all the two lines I am going to consider. And here the line 1 passes through the point. I am going to take it as say A with the position vector as A1 vector. That means OA vector will be is equals to, so A1 vector. Understood? Similarly, that vector will be parallel to B1 vector. So that only I have got the equation as R vector is equals to A1 vector plus lambda into B1 vector. Similarly, the line L2 will be passes through the point B. I am going to take that point B, and that position vector will be is equals to A2 vector, and then that A2 vector will be parallel to B2 vector. So here I am going to take it as OB vector will be is equals to A2 vector. Understood? And this is parallel to B2 vector. Now, by this condition, the line will be what? A to B. Okay. So therefore, the line AB vector can be written as, which will be is equals to OB vector minus OA vector. Right? Position vectors. Now, what is OB vector minus OA vector? Which is nothing but AB vector is equals to OB vector. We know it is A2 vector. So, A2 vector minus A1 vector. So, this you have to note down. And then here the AB is perpendicular to what? If A1 and A2 are parallel to B1 and B2, then you are going to have the line AB is perpendicular to B1 and B2. Therefore, you are going to consider AB vector is perpendicular to B1 cross B2. Therefore, you can have AB vector dot B1 cross B2 will be is equals to what? 0. The dot product will be is equals to 0 whenever the line is perpendicular to that. Okay. Now here AB vector you know A2 minus A1. Therefore, substituting that A2 minus A1 vector dot product of B1 cross B2 is equals to 0, and this is going to be known as the vector form of coplanarity of two lines. Okay, that's it, yes. How easier to derive, isn't it? Now, we'll be moving on to the Cartesian form. Now, for the Cartesian form, I have to take the coordinates of the position vectors. Now, here I am taking for the Cartesian form, so I am going to take it as let x1, y1 and z1, be the coordinates of the position vector a1 vector, and x2, y2, z2. Okay, be the coordinates of the position vector OB vector, which is a2 vector. So consider, let x1, y1, z1 be the points of a point A. Therefore, you can have OA vector will be is equals to A1 vector will be is equals to x1I plus y1j plus z1k, right? So similarly, you are having let x2, y2, z2 be the points or the coordinates of B. Okay, therefore OB vector will be is equals to A2 vector will be is equals to x2I plus y2j plus z2k. Got? Now here I am considering a direction ratios of a parallel vectors b1 and b2. So what are all the direction ratios I am going to assume? So I am going to assume that let a1, b1, c1 and a2, b2, c2 be the direction ratios. Be the direction ratios of what? So be the direction ratios of b1 vector and b2 vector. So therefore you can have b1 vector will be is equals to a1i plus b1j plus c1k. Similarly, b2 vector will be is equals to a2i plus b2j plus c2k. That's it. Now, what you need to do for the Cartesian form? You have to do a2 minus a1 because a2 minus a1 dot b1 cross b2 will be is equals to 0. So, therefore, you can have a2 minus a1 is what? a2 minus a1 is x2 minus x1 into I, y2 minus y1 into j. Let me write it here. So, a2 minus a1 vector will be is equals to x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. Got it? Now here, since we are having a scalar triple product, that determinant will be is equals to what? A coefficient of a2 minus a1 in the first row. In the second row, we are having coefficient of a b1 vector. In the third row, we are having coefficient of b2 vector. That determinant will be is equals to 0. So that is a Cartesian form of the coplanarity condition. Now we'll be writing in the Cartesian form, which is equal to a2 minus a1, which is x2 minus x1 and y2 minus y1 and z2 minus z1, and then here coefficient of b1 vector, which is a1, b1, c1, and coefficient of b2 vector a2, b2, c2, a2, b2, c2 will be is equals to 0. This is going to be known as the Cartesian form of the coplanarity of two lines. Understood? So vector form and the Cartesian form. Vector form is a2 minus a1 dot b1 cross b2 will be equals to 0, and the Cartesian form will be determinant of this will be is equals to 0. Now based on this, we'll be solving the problem now, dear students, so that you will get an idea. Okay, now we'll be moving on to the problem. What they've asked: show that the lines x plus 3 divided by minus 3 will be equals to y minus 1 divided by 1 equals to z minus 5 divided by 5, and x plus 1 divided by minus 1 will be equals to y minus 2 divided by 2, and it will be equal to z minus 5 divided by 5 are coplanar. If they ask the coplanar, you can have the determinant of that. First, let me introduce you. The lines are in the form of what? X minus x1 divided by a1 is equals to y minus y1 divided by b1 is equals to z minus z1 divided by c1. Similarly, the line 2 will be in the form of Similarly, the line 2 is in the form of x minus x2 divided by a2 is equals to y minus y2 divided by b2 is equals to z minus z2 divided by c2. Therefore, you come to know now what are all the values of x1, y1, z1, a1, b1, c1, x2, y2, z2, a2, b2, c2. Now, let me write it. For your reference, x1 value here negative, so positive, negative of positive will be negative. So x1 will be is equals to minus 3. Similarly, y1 will be is equals to, you are having 1 and z1 will be is equals to plus 5. So let me write and then x2, y2, z2. So x2 will be is equals to minus 1 here and y2 will be is equals to 2 and then z2 will be is equals to 5. So let me write it. A1, B1, C1. A1 is nothing but minus 3 and B1 is nothing but you are having 1 and C1 is nothing but here 5. Similarly, A2, B2, C2, which is A2 will be minus 1, B2 will be 2 and C2 is nothing but 5. Correct? Now, what you are going to do, you are going to have the expansion of that must be equals to 0. Then only you can show that the given two lines are coplanar. Now, here I am taking the expansion of that. What is that? You are having the formula x2 minus x1, y2 minus y1, z2 minus z1 and then here a1, b1, c1, a2, b2, c2. Must be equal to 0, then only you can prove that the given two lines are coplanar. Now, taking x2 minus x1, minus 1 minus of minus 3. Minus 1 minus of minus 3 is plus 3. So, minus 1 plus 3 gives you the value what? It will be giving you the value minus 1 plus 3 is 2. Similarly, y2 minus y1, 2 minus 1 which will be 1. And z2 minus z1, 5 minus 5 will be 0. Similarly, a1, b1 value that is minus 3, 1 and 5. Minus 3, 1, 5. a2, b2 value, c2 value which is minus 1, 2 and 5. So, minus 1, 2 and then 5. So, let us expand these determinant. Now only don't put 0 because after expanding we have to get it as 0. If you are getting as 0 then it is coplanar, otherwise it is non-coplanar. Understood? Now let me expand this one. How to expand? This is a positive, negative and then positive. Now leaving what is that? First column and the first row you can have 2 into, see, leaving the first column, first row, 1 into 5 is 5 minus 5 2s are 10 minus what is there here? 1. Again, leaving the second column, first row, minus 3 into 5 which is minus 15 minus, already one minus is here, another minus is here, minus into minus which will become plus. So, here minus 1 into 5 is plus 5. Again plus, you are having 0. Anyway, 0 into anything will be the 0 itself. So, if you want, you can, leaving the third column, first row, minus 3 into 2 which is nothing but minus 6. Now, already one minus sign is there and here 1, minus 1 into 1 which is plus 1 which will become. Anyway, 0 into anything will be 0. So, we are not going to consider that. So, here let me solve this. So, 2, 5 minus 10. 5 minus 10 is nothing but minus 5. Minus 5 into 2 which is minus 10. Again, here minus 15 plus 5 which is nothing but minus 10. Minus 10 into minus 1 which is plus 10. So, plus 10. Anyway, this is 0. We are neglecting that. Minus 10 plus 10 will get cancelled, which will be is equals to 0. Now, you got after the expansion of the determinant, it is equals to 0. Therefore, the given two lines are coplanar. So, you are going to conclude the condition as therefore, the given two lines are coplanar. Okay. I hope you understood this one, how to solve. This type of problem will be asked for a 3 marker in your final examination if they do not ask the derivation. Now, we'll be moving on to the next problem, what they've asked. If the lines x minus 1 divided by minus 3 is equals to y minus 2 divided by 2 is equals to z minus 3 divided by 2 and x minus 1 divided by 3k is equals to y minus 1 divided by 1 equals to z minus 6 divided by minus 5 are coplanar, find the value of k. Already they have given these lines are coplanar, so that you need to find out the value of k. Then I can take the determinant will be equals to 0 since the given lines are coplanar. Okay. In the last case, they have asked you to prove that the coplanar, so that I did not take the determinant equal to 0. I proved that determinant equal to 0. In this case, they have already given the lines are coplanar. So what I am taking? I am taking the determinant will be equals to 0. Substituting the values in the 3 rows, we are going to find out the value of k. Understood? Now here, first it is x1, y1, z1. I am writing x1 is equals to 1 and then y1 is equals to 2 and z1 is equals to 3. Similarly, let me write x2 is equals to second line 1, y2 is equals to 1, z2 is equals to 6. And then what is a1, b1, c1? a1 is equals to minus 3, b1 is equals to 2 and then c1 is equals to 2. Similarly, A2 will be is equals to 3k and B2 will be is equals to 1, C2 is equals to minus 5. Now, let me take the determinant and then expand that and equate it to a 0. Now, what is the determinant? Let me write the formula first. x2 minus x1, y2 minus y1, z2 minus z1 in the first row, a1, b1, c1 in the second row, a2, b2, c2 in the third row. That determinant will be equals to 0. Let me substitute the values here. What is x2 minus x1? 1 minus 1 will be equals to 0. And then y2 minus y1, 1 minus 2 will be equals to minus 1. z2 minus z1, 6 minus 3 will be is equals to 3. a1, b1, c1 minus 3, 2, 2 and then a2, b2, c2, 3k, 1 and then minus 5. So that determinant, let me expand and equate it to a 0. So leaving the first row, first column, so you can have 0 into anything will be 0 only. So 2 into minus 5 which is minus 10. Again minus 1 into 2 is 2. Again plus, see here minus sign will be there, minus into minus it will become plus because plus minus plus. So minus of minus will be plus 1 into, leaving the second column first row, minus 3 into minus 5 which is plus 15. Again minus 3k into 2, 3 into 2 which is nothing but 6. So 6k, right? Again plus 3, leaving third row, first column, minus 3 into 1 is minus 3 and then minus 3 into 1 is minus 3. Now 3k into 2 is nothing but 6. So you can have minus 6k will be equals to 0. Now let me evaluate this. So this will be equals to 0. Now here 15, 1 into 15, let me multiply 15 minus 1 into 6 is 6k. Again here 3 3s are plus into minus is minus, 3 3s are 9, plus into minus is minus, 3 6s are 18 is equals to 0. Now let me, what is that? Add the k terms and the constant terms. Now 6k and then 18k, it will be giving you 24k. So 15 minus 9 gives you the value 6. So here you can have 15 minus 9 is nothing but 6. Minus 6k minus 18k is minus 24k will be equals to 0. Shift 24k to that side. So 24k will be is equals to 6. Or you can have k will be is equals to 6 divided by 24, or you can have K will be is equals to 6 ones are 6 fours are, so 1 divided by 4. And this is the value of K you are going to get after equating the determinant to 0. Understood? This is how you are going to find out the value of K, which will be asked for a 3 marker. Either the first type problem or the second type of problem, they may ask it in the final examination. Now, we'll be moving on to the next concept of 3D geometry, if nothing but an angle between two planes. What is the angle between the two planes? Here, definition I have given like this. So, the angle between the two planes is defined as the angle between they are normals. So, it is nothing but here their normals is, see, plane 1 will be having a n1 as a normal, and here plane 1 will be having a n1 as a normal, plane 2 will be having a n2 as a normal. Understood? So, here observe that if theta in this diagram, if theta, see, if theta is an angle between the two planes, this one, if theta is an angle between the two planes, then 180 minus theta, here you can observe here, because I have taken this diagram, okay, this is 180 minus theta. Understood? So 180 minus theta, you can observe here the same planes I have taken to show you 180 minus theta how it will come. So 180 minus theta will be the angle between the two planes. So we shall take the acute angle as the angles between the two planes. What is that? We are going to take it as acute angle. Got? So this is very important. Why I have taken like that? You can see here 90 minus of 90 minus theta, which will be giving you, see, if you multiply 90 minus 90 minus into minus plus theta, so it will get cancelled. You are going to remain with theta. So that only, that is called as the angle between the normals. So that's what I have taken here. Got? So therefore theta is an angle between that two normals. So this diagram is very important for you. Okay, now let us expand the equation based on the condition. Let n1 and n2 vector be the two normals, okay, two normals. So, and then theta be the angle between the normals, okay, between the normals. Therefore, what is cos theta is given by, so you are having cos theta will be is equals to magnitude of n1 vector dot n2 vector divided by magnitude of n1 vector into magnitude of n2 vector. So this is what the formula you are going to get it as. Now this is called the Cartesian. Now this is going to be known as the vector form. Now we'll be moving on to the Cartesian form. So I am going to take it as here n1 vector. So this is called the vector form or the angle between the two planes in the vector form. Now we'll be moving on to the Cartesian form. So in the Cartesian form I am taking, so in the Cartesian form, so I am going to take it as let a1x plus b1y plus c1z plus d 1 equals to 0 and a2x plus b2y plus c2z plus d2 will be equals to 0 be the two lines of that planes. Now here be the two lines. Therefore, you can have cos theta will be is equals to magnitude of a1 a2 plus b1 b2 plus c1 c2 divided by under the root of a1 squared plus b1 squared plus c1 squared under the root of a2 squared plus b2 squared plus c2 squared. Okay. So this is going to be known as what? The determinant of that or cos theta of the Cartesian form. So therefore here you are having two conditions. What are all the two conditions? When the plane 1 is perpendicular to plane 2. What about the cos theta you are having? So here I am writing the condition. So when plane 1 is perpendicular to plane 2, then we have A1, A2, B1, B2 plus C1, C2 will be equals to 0. This is a condition. Suppose if plane 1 is parallel to plane 2, then we are having ratios will be equal. That is A1 by A2 is equals to B1 by B2 is equals to C1 by C2. That's it. Understood? So this is what the condition you are going to have when the two planes are perpendicular and when the two planes are parallel. That's it, dear students. Now we'll be moving on to problems based on this formula. Now here we are having find the angle between the two planes 2x plus y minus 2z is equals to 5. So they have given two planes are what? Given two planes which is 2x plus y minus 2z is equals to 5 and then 3x minus 6y minus 2z is equals to 7 using the vector method. They have asked you to use the vector method. That means cos theta is equals to magnitude of n1 vector dot n2 vector divided by magnitude of n1 vector dot magnitude of n2 vector. Now let me take it as here, which is in the form of C. You can have your j k, which is 2I plus 2j, coefficient of n1 vector, which is given by n1 vector is equals to, you can take this one as 2I plus j minus 2k. Similarly, you can have n2 vector of the line 2, which is 3I minus 6j minus 2k. Okay. So, and then they have given D1 and D2 here. So, here you can write D1 will be is equals to 5 and D2 is equals to 7. Now, what is cos theta is given by? So, cos theta will be is equals to n1 vector dot n2 vector divided by magnitude of n1 vector into magnitude of n2 vector. Now, let me write n1 dot n2. What is n1 dot n2? I dot I will be is equals to 1, which you can have. So, if you want, you can write 2I plus j minus 2k into dot product of 3I minus 6j, 3I minus 6j minus 2k divided by magnitude of that means what? Under the root of 2 squared plus 1 squared plus minus 2 whole squared, coefficient of ijk, into under the root of 3 squared plus minus 6 squared plus minus 2 whole squared. Okay. So, this is what you are going to calculate. Now, you can multiply 2 into 3, which is I dot I1. So, therefore, cos theta will be is equals to 2 into 3, which is nothing but 6, again plus 1 into minus 6, which is nothing but minus 6, right? So, minus 6, again minus 2 into minus 2, which is nothing but plus 4, divided by here square root of 2 squared is 4, again 2 squared is 4, 4 plus 4, 8 plus 1, 9, under the root 9 into under the root of, you can have 3 squared is what? Which is 9. Again 6 squared is 36. 36 plus 9 gives you the value 45. So, 45 plus 2 squared is 4, 49. So, under the root 49. Let me calculate this. So, plus 6 minus 6 will go. So, therefore, cos theta will be is equals to 4 divided by under the root 9 is 3 into under the root 49 is 7. So, cos theta will be is equals to 4 divided by 21, or theta will be is equals to cos inverse of 4 divided by 21. This is what you are going to find out by vector method. Understood? Now, we'll be moving on to the next problem what they have given. find the angle between the two planes 3x minus 6y plus 2z is equals to 7 and 2x plus 2y minus 2z is equals to 5. Now you can take it as angle between the two planes either in the vector method or in the Cartesian method. So here they have not mentioned anything. You can go by the vector method or you can go by the Cartesian method. Okay, so the last case we have proved by the vector method, you come to know. Now here we'll be moving on to the Cartesian method. Now it is in the form of what? 3x minus 6y plus 2z. Let me take 7 to this side, which is minus 7 equals to 0, which is in the form of a1x plus b1y plus c1z plus d1 is equals to 0. Similarly, what the next equation they have given? 2x plus 2y again minus 2z plus 5 to that side, which is minus 5 equals to 0, which is in the form of a2x plus b2y plus c2z plus d2 equals to 0. Now you come to know the value of a1, b1, a2, b2, c1, c2 and then d1, d2. So what is the cos theta is given by in the Cartesian form? Cos theta is equals to magnitude of a1, a2 plus b1, b2 plus c1, c2 divided by under the root of a1 squared plus b1 squared plus c1 squared into under the root of a2 squared plus b2 squared plus c2 squared. Now let me have substituting this a1, a2. What is a1 here? 3. A2 here 2. Similarly b1 here minus 6. b2 here 2. c1 2. c2 is minus 2. d1 is minus 7. d2 is minus 5. Multiply a1 and a2. 2 into 3. Correct. So which is given by, you can have 2 into 3 and then plus you are having plus 2 into minus 6, which is minus, you can have, so minus 6 into 2 again c1 into c2 minus 2 into plus 2, which is again minus, so minus 2 into plus 2 divided by under the root of what? a1, b1, c1. So here 3 squared, 6 squared, 2 squared. So 3 squared plus minus 6 whole squared plus 2 squared. Similarly, under the root of a2 squared plus b2 squared plus c2 squared. You know the value a2, 2 squared plus 2 squared plus again minus 2 squared, right? So let me evaluate this. You are going to get it as cos theta will be is equals to magnitude of 2 3s are 6, 2 3s are 6 minus 6 2s are 12 minus 2 2s are 4 divided by under the root of 3 squared is 9, 6 squared is 36, 36 plus 9 is 45, 45 plus 2 squared is 4, 49. Under the root 49 into under the root 2 squared plus 2 squared plus minus 2 squared, which will be giving you 2 squared is 4, 4 plus 4 plus 4, correct, which is 12. So under the root 12. Now you can evaluate still. So here you can have 6 minus 12, which is minus 6, minus 6 minus 4 is minus 10. So you can have under the modulus minus 10 divided by root 49 is 7. So you can write 12 as 4 into 3. 4 into 3, 4 you can take outside the square root, which will become 2. So into 2 root 3. So which will be giving you 7 2s are 14. So you can have cos theta will be is equals to 10 divided by, you can have 14 root 3. Otherwise cos theta you can cancel here, 2 5s are 2 7s are. So therefore theta will be is equal to cos inverse of 5 divided by 7 root 3 is your answer by Cartesian method. So you understood this method. Now we'll be moving on to the next formula. Now here I have taken distance of a point from a plane. So distance of the point from a plane. So here I have taken the point as P and Q of the plane pi 1 and the plane pi 2. Okay, so why I have taken like this? See, consider a point P with the position vector A vector. Point P is with the position vector A vector. You can see it here. And consider the plane which is a pi 2 through a P parallel to the plane as pi 1 vector. What is a line 1? That is a plane 1 equation will become r vector dot n cap is equals to d. Similarly, the unit vector normal to the pi 2, which is this one. The unit vector is normal to the pi 2 vector. Okay. So, pi 2 vector. So, let it be is equals to n cap. So, hence its equation will become r vector minus a vector dot n cap, this one, r vector. So, which is you are having OP will be is equals to a vector and then OQ will be is equals to r vector, which is r vector minus a vector with the unit vector of the dot product will be is equals to 0. Therefore, you can write r vector dot n cap will be is equals to a vector dot n cap. So, that is what you are going to have. Thus, the distance ON dash, this one. So, the distance you are going to have ON dash, this is. So, the distance ON dash of this plane from the origin will be is equals to magnitude of a vector dot n cap. Therefore, you can have the distance will be PQ from the plane pi 1. So, this is what the distance you are going to have, PQ from the plane pi 1. So, this is what you are going to have. Therefore, ON minus ON dash gives you D minus A vector dot n cap. So, which is nothing but the length of the perpendicular from a point to the given plane. Understood? So, this is a formula of the vector form. So, in the Cartesian form, you can have let, I am considering here, let P of x1, y1, z1 be the point on the plane, be the point on plane of a vector, of the position vector of a vector. So, you can have a vector will be is equals to x1i plus y1j plus z1k. So, and then you are having let the line be let ax plus by plus cz plus d equals to 0 minus d equals to 0 be the line on that. So, therefore, perpendicular distance is given by d will be is equals to, you are having magnitude of a x1 plus b y1 plus c z1 minus d divided by under the root of a squared plus b squared plus c squared. Okay. So, this is what the perpendicular distance formula is given as. Understood? Now, based on this, dear students, will be having a problem. So, find the distance of a point 2, 5 and minus 3 from the plane r vector dot 6i minus 3j plus 2k is equals to 4, which is a form you are having the point they have given. Given point is 2, 5 and minus 3, which is nothing but x1, y1 and then z1. Okay. And then they have given the plane as, what is that? R vector dot n cap will be is equals to, correct, d vector, right? So, therefore, n vector will be is equals to what? 6i minus 3j plus 2k and d will be value as d will be is equals to 4, right? If you want, you can compare here. So, r vector dot 6i minus 3j plus 2k will be is equals to 4. So, which is in the form of this. So, I am writing the value. So, what is the perpendicular distance is given by? Perpendicular distance is given by magnitude of ax1 plus by1 plus cz1 minus d divided by under the root of a squared plus b squared plus c squared. Now, this is the formula you are going to have. Let me substitute the values. What is that? So, d will be is equals to ax1. What is that? ax1, 6 into, see a, it is a value of a, x1. So, 6 into x1 value is nothing but 2 So plus and dy1 minus 3 into what is that 5. So 5 again plus which is 2 into c value is, and z1 value will be is equals to minus 3 minus d value you know it is 4. So minus 4 divided by under the root of ax1 which is 6 squared, by1 which is minus 3 squared, a squared b squared plus cz1 which is 2 squared. Now let us evaluate this. So d will be is equals to 6 2s are 12, 3 into minus 3 into 5 is minus 15, again plus 2 into 3 is minus 6, minus 4 divided by under the root of 6 squared is 36 and 3 squared is 9, 36 plus 9 is 45, 4 squared is 2 squared is 4, so 6 squared is 36, 3 squared is 9, 36 plus 9 is nothing but 45, 2 squared is 4, 45 plus 4 is 49, so under the root 49. So let me evaluate still here. So you can have 12 minus 15 which is nothing but minus 3. So minus 6 minus 4 is minus 10. Minus 10 minus 3 is minus 13. So magnitude of minus 13 divided by under the root 49 is 7, but distance cannot be negative. So therefore inside the magnitude the negative value will become positive. So which is 13 divided by 7 is your answer. So that's it dear students. I hope you understood all the derivations based on that problem. So in the next session, we'll be moving on to the one more concept of your 3D geometry. So until then dear students, keep watching. Thank you. Have a nice day.